All right, section 1.2, interpreting data in graphs. The first thing we're going to look at is a bar graph. So I know all of these graphs seem kind of simple, but I do want to get into some important key points, even if you're very familiar with bar graphs. So the first thing that we see here is some definitions that we think are important for 1342. So here's qualitative data or categorical data. So these two words here are the same, qualitative, categorical. They can be used interchangeably. This is information that consists of categories or non-numerical entries. So what are examples of categories? Such things as apple, orange, banana, kiwis, blueberries, grapes, A, B, C, or D. Sometimes you might see graphs with like giraffes, animals, names, something like that. So it's just categories. Most importantly, here it says non-numerical, no numbers. So bar graphs or bar charts are used to graph categorical information. The categories for bar graphs can be labeled horizontally or vertically. So horizontally is like this, right? So we're seeing the categories here. Or vertically, so you see the stuff on this side. The bar graph counts the data on the other axis. So if this is the category, then this over here is the count. In this case, this is the category, and so this is going to be the count. The bars in a bar graph should not touch. That's really important because later we're going to see a graph that does touch. So just to point this out, you see there's space here. There's no touching, okay? So you have a very clear idea of where the apple, bar graph, bar starts. This is all of the bar. And then this is very clear that this is where the orange starts. So, moving forward, we also have pie charts, and we'll come back to those in a little bit. Well, actually, let's do it now. Pie charts or pie graphs are used to graph categorical information. So this also graphs the same thing, which is why we put it in the same box. So pie charts categories can be labeled as the pieces of the pie or slices. Slice a circle in pieces to label the categories. So we have the different categories here, and of course you've seen the slices, right? So it's very clear that this is one slice, and then this is the information regarding that slice. Okay, let's move forward. So we have some examples. The way this is going to work is most of the time I'm going to be able to show you one and you're going to try one. Okay, so here, let's take a look at the first one. So the first one is about a bar graph. It says your math professor made a bar graph of students' overall grades for one class. The grade was recorded as a letter grade. So we have A, B, C, D. So pausing here, I want you to notice that we have categorical data, right? That it's not a numerical value. The grade, the number of students who earned that grade is displayed in the bar chart below. So if this is our category data, then this is the count. This one's really nice and easy. We're starting you off with baby steps because you see the count here. Otherwise, if that count wasn't there, let's pretend that wasn't there, I would have to come to this side and count it, right? So I would have to kind of follow this across and estimate what that was. But luckily they are here. So in this case, we get to see that value. So these are the first things that I like to do before I start answering. Point out key points to look at in a graph. Your key points are to look at a title. Students often ignore the title. They just want to go straight to the questions. And that's not the goal. You got to gather all the data. You got to see if you understand the graph and then go and answer those questions. So title, it's student grades. Next thing we see is the axis. What's on the axis? So I see that the x-axis is categories. The y-axis is the count. So I'm able to look at those. And then I kind of observe, the grades, the amount of students. Like for example, here I can say, well, there's not more than 30 students getting one single grade, right? Another thing we want to look for is we get a key. Sometimes a graph gets a key. In this case, this one does not, but sometimes it does, and that's really important. The last thing, and which is the most important thing ever, I want you to make a sentence. Now, this doesn't have to be part of your questions, it's just part of what you do when you're learning to read a graph. I want you to make a sentence for yourself that shows that you understand what the graph is about. So, I encourage you just to pick a random place. So, I'm going to pick this bar. And what I'm going to do is I'm going to create a sentence regarding this bar. Okay? So, I'm going to say that 10 students received a C. And that's it. So to me, I was able to put my sentence together so it shows me, right? It's not for anybody else. It shows me that I understand. I understand all the words being used. I understand the data being presented. If you don't understand, that's when you say, I need help. You cannot answer questions of a graph you don't understand. Okay, we're ready. What letter grade did most students receive in this class? Most students. What are we looking for? We're looking for the tallest bar. That's what's really neat about bar graphs, is that they're so easy to read. So most will indicate tallest bar. And so most students received a B. I'm encouraging you to write in complete sentences. And if it says you need to answer in a complete sentence, you should. What letter grade did the least number of students get in this class? So which one was the least number? This is going to be the smallest bar, right? Shortest bar. Who's the shortest bar? D. We're going to put the least students. So the least received grade in the class was a D. How many students passed the class? So what's passing? And this is relevant to us here in college, A, B, or C. So how many students passed the class? So we're looking at A. A is 4. B is 12. And C is 10. So let's do that. 4 plus 12 is 16, plus 10 is 26. All right, so 26 students passed the class. How many students failed the class, which is did not earn an A, B, or C? So what is failing? Failed is a D. So how many students failed? 2 students failed. How many total students were in your math professor's class? So how many students did you see total? So we had 4 plus 12 plus 10 plus the 2 that failed. So we have 28. All right, easy peasy, right? And I mean easy peasy about the sentences. Sometimes when we're learning stuff, it's not that easy. So I don't mean the math. I mean easy peasy about putting some sentences together, okay? Create a question that would collect the information found in this bar graph. All right, so now when we ask you this question, I want you to picture yourself as a scientist, right? Like going around the city and you're picturing what this person would be asking you in order for this information to be collected. And so I would do something like, I think that. And then we might even have to be more specific in saying what grade, because sometimes I could say, oh, well, I received a 75, right? And maybe that's not what you're going for. So I would have to say, like, what letter grade did you receive this semester? And so you start seeing how it is that people collect data. Let's identify interesting features in the bar graph. Let's look for big ideas instead of individual entries. What we want from this part of the course from you is some big thinking. Like when you look at something, what do you think? Wow, this stands out to me. Not just a little thing like, I'll show you what a little thing is. 2 students received a D. That's little. What we want is a big idea, like I'm going to share a big idea. Most students pass this class. And this is true, right? So if I went into rate my professor, then I can say most students pass this class because it's true, only 2 students got a D. We can say very few students fail the class. But overall, what I want to emphasize is a big idea. Let's number 2, and you can try it.